Let's talk about solving systems of equations. 2x plus 4y equals 13, negative 3x minus 7y equals 21. And you probably know how to solve this. We're going to multiply each of the equations by some number that will allow us to eliminate a variable, and we can work our way through and process it. I made up these numbers. I don't know what the solution is, but there's a good chance that they're not nice numbers, that they're some awkward fraction. We won't know until we get there, and so then it takes a little bit of time. But I want to show you a little bit of something about matrices. And so I'm going to take this system of equations and I am going to put these numbers into a matrix, and I will show you in just a second exactly why I chose or how I wrote these. And I'm going to assume that you have a basic familiarity with matrices. So the way a matrix multiplication works, just to either refresh or introduce you, is that we multiply a row times a column. So we will multiply this row by this column, that is row 1, column 1, and we will multiply this row by the same column, that is row 2, column 1. And we multiply by working our way through and adding. Come on, go away. So 2 times x plus 4 times y. There's our first row, first column. Second row, negative 3 times x plus negative 7 times y. And the result of that multiplication is the left-hand side of our system of equations, and therefore 2x plus 4y must equal 13, and negative 3x minus 7y must equal 21. Well, how does that help us solve? Well, if I go back to my matrices, and I'm going to go ahead and rewrite it since I wrote all over. Let's call this matrix A. This will be our variable matrix X, and let's call this matrix B. Obviously, I could solve for X if these were numbers by dividing. I can't, however, divide matrices. It doesn't work. But what I can do is I can multiply by the multiplicative inverse. Just a reminder that to solve for 2x equals 4, I could divide by 2 to get x equals 2. Or I can multiply both sides by 1/2, the multiplicative inverse of 2, and I get the same answer. I get x equals 2. So I need to multiply by the multiplicative inverse. Again, just as a reminder, order matters in matrix multiplication. So I'm going to lead off each side with multiplied by A inverse. I'm going to squeeze my B right in there. This is the identity matrix, also known as 1 in matrix terms. And I get that x is equal to A inverse B. Okay, that's easy enough, but what the heck is A inverse? Well, it turns out that my calculator will do it for me. Didn't really want it to be quite that big because I can't see my, come on. Shrink, there we go. And let's bring that down. If I go to, what's going on here? My touch sensor is working a little sketchily. There it goes. If I go to matrix, which is a button on any graphing calculator, and I'm going to go over to edit, and I am going to enter matrix a 2 by 2 matrix, and I'm going to put in the numbers that I have in my original matrix here, which I can't see anymore. 2, 4, negative 3, negative 7. So back to my calculator. 2, 4, negative 3, negative 7. Just check myself. Yep. And then I'm going to go to matrix B, and I'm going to edit it, and it will be a 2 by 1 matrix, 2 rows by 1 column. And I have a 13 and a 21. And now I can go back to the main screen, and I can choose matrix A. I use the x to the negative 1 key to get the inverse, and I will multiply that by matrix B, and I get that the solution to my system, as I suspected, is some pretty horrible numbers. 6.7 and negative 0.12. So 6.73, negative 0.12. X equals 6.73. Y equals negative 0.12. Boom, system solved. So pretty straightforward process. And I could do the same thing, and I won't work my way through the solution process, but if I had a system of 3 equations, 3 variables, which you may be familiar with from your Algebra 2 work, I can similarly write a set of matrix equations, and the difference will be that I will have a 3 by 3 matrix multiplied by x, y, z. There's my first equation across the top, my second equation across the middle, my third equation across the bottom, and that equals 2, 19, negative 20. And if I were to plug in this into my calculator, notice again it's going to be A inverse B, and my calculator is going to do all the work for me. We go back to the calculator, we bring up the view screen so we can see it. We go back into our matrices, only this time a matrix is going to be a 3 by 3. And I'm not going to actually work through the process because I think you get it. You can now enter the 9 values from your 3 by 3 matrix and multiply the inverse of that times the 3 values from your 3 by 1 matrix. So this is all an introduction from my calculus class to something that we're doing that is going to involve solving a lot of systems. But perhaps you've been wondering how to use matrices to solve systems of equations. The nice thing about this is that a 3 by 3 system takes a long time to solve by hand, plenty of opportunity for mistakes. And now what about 4 by 4, 5 by 5, 6 by 6, or bigger systems of equations? All right, thanks for watching. Hope you learned something.